Good morning, students. Today we shall discuss the next topic, that is from sequence and series, geometric progression. So far we have seen arithmetic progression and how sequences and series looks like. Today's topic is geometric progression. A geometric progression is a sequence where every term bears a constant ratio to its preceding term. In case of arithmetic progression, we have seen the difference between two consecutive terms were constant. That was called as common difference. Whereas in this case, it is the common ratio. It has to be a constant ratio. Geometric progression is a special type of sequence. In order to get the next term in the geometric progression, we have to multiply with a fixed term known as the common ratio, and that is represented by small r. Every time, if you want to find the preceding term in the sequence, we just have to divide the term with the same common ratio. Here is an example of geometric progression: 2, 4, 8, 16, 32, and so on. If you want to get the common ratio, let us divide the second term with the preceding term, that is the first term. So it is 4 by 2. Everywhere, now if you do a3 by a2, the third term by the second term, it is 8 by 4. The answer will be 2, which is constant. If you do a4 by a3, it will be constant, having a common ratio of 2. The geometric progressions can be a finite series or an infinite series. The common ratio of a geometric progression can be negative or a positive integer. Here we shall learn more about the geometric progression, formulas, and the different types of geometric progressions. A geometric progression is a special type of sequence where the successive term bears a constant ratio, known as the common ratio here. And it is generally represented in the form of ar square, and then ar cube. It goes till ar power n, where a is the first term and r is the common ratio of the sequence. The common ratio can have both negative as well as positive values. This is how the GP looks. The first term is a, the second term is ar, the third term is ar square, and the nth term is given by ar and minus 1. The geometric progression is of two types. The two types of geometric progressions are based on the number of terms in the progression series. The details of two geometric progressions are as follows. First is finite geometric progression. In finite geometric progression, the geometric series that contains a finite number of terms. Like if you see, it is ending till 1 by 32768. 32,768. That means it has got the finite series. Whereas, if you talk about infinite, when we place dot dot dot, that means what? It is going till n terms. We don't know where it will end. So it becomes infinite series. So last term is not defined here. Geometric progression formula. The geometric progression formula is used to find the nth term of the sequence. To find the nth term in the geometric progression, we require the first term and the common ratio, and it is given by an is equals to ar to the power n minus 1, where a is the first term, r is the common ratio, n is the number of terms which we want to find. Okay, so if you have got all these values, you can easily get the value of an, okay, where n is the number of terms which we want to find. For the sum, we need to convert the sequence into series, and then we apply the formula of the sum, right? So the sequence, the geometric progression, sum formula is used to find the sum of all the terms in the geometric sequence. As we read in the above section, that geometric sequence is of two types, that is finite and infinite geometric sequences. Hence the sum of their terms is also calculated by different formulas. Finite geometric series. If the number of terms in a geometric sequence is finite, then the sum of geometric series is calculated by the formula Sn is equals to a 1 minus r power n upon 1 minus r for r not equal to 1, and Sn equals to an for r is equals to 1. If r is equals to 1, then the sum of the nth term of a geometric progression is given by an. For example, if we have a natural number sequence till nth term, so sum of this will be an, where a, if it is 1, so it is only n. Okay. Now if you apply the formula here, you will get the value as an for r equals to 1. So here r is the common ratio and is the number of terms in that series. For infinite geometric series, if the number of terms in a geometric sequence is infinite, an infinite geometric series sum formula is used. In infinite series, there arises two cases depending upon the value of r. Let us discuss. When mod of r is less than 1, S infinity is equals to a divided by 1 minus r, where a is the first term, r is the common ratio. For mod of r is more than 1, in this case the series does not converge and it has no sum. Remember, modulus of r, it depends completely upon the modulus of r for the infinite series sum. That's all from today class. We'll try solving more questions from NCERT, and as per the given works, if you face any problem, you can ask in your virtual class. Thank you.